All right, we'll get started with 22. They give you f prime, the derivative of f is shown in the graph, and they tell you that f of 0 is 5, and they want to know what f of 1 is. So if we know that f prime is going to be linear, and we have basically 2 points on the line, we know this point is going to be 0, 6, and we know that this point is going to be 1, 0. We can come up with the equation of that line. So we can find the slope by doing a rate of change. So it's going to be y2 minus y1 over x2 minus x1. So we're going to get a negative 6 to be the slope. And then we can actually come up with the equation. Let me say I'm going to use this point. So y minus 6 is equal to a negative 6 times x minus 0. So y minus 6 is equal to negative 6x. And then add 6, so y is equal to negative 6x plus 6. So this is the equation for that line. And then what we want to do is we want to try to find out if I know that f of 0 is 5, we can work backwards by integrating negative 6x plus 6 dx. And we're going to get negative 6x squared over 2 plus 6x, which equals 3x squared, negative 3x squared, plus 6x. And we know that, and then plus c. And then we know that at 0, this thing's going to be 5. So 5 is going to equal, plugging in 0, you get 0 plus c. So you know that c is equal to 5. So you get the equation y is equal to negative 3x squared from over here, then plus 6x, and then plus 5. And they want to know what f of 1 is going to equal. So f of 1, plugging 1 in, you get negative 3 plus 6 plus 5. That's going to be 3 plus 5 or 8. Choice D. Moving on to question 24. Question 24 says, let f be the function defined by 4x cubed minus 5x plus 3. Which of the following is the equation of a line tangent to the graph at x equals 1? Well, a tangent line, again, we're going to take the derivative. The derivative is going to be 12x squared minus 5. And we're going to take the derivative and evaluate it at negative 1. So when we plug negative 1 in, we're going to get 12 minus 5, and we're going to get 7. So there's my slope. So I go y minus my y1, which I'm not sure yet, equals 7 times x minus a minus 1, which is plus 1. Now to find out what the y1 is going to be, we take the negative 1 and we substitute it in for, I want to find f of negative 1. So I can figure out what the point is going to be. So I plug it's 4 times negative 1 cubed minus 5 times negative 1 plus 3. This is going to be a negative 4 plus 5 plus 3, and that's going to be 4. So that's a 4. So y minus 4 is equal to 7x plus 7. Add 4 to both sides, you get 7x plus 11 as an answer. Choice C. Question 25. Question 25 goes on to say, particle moves along the x-axis, t greater than or equal to 0. Remember, this is just setting the domain. T has to be greater than or equal to 0. Its position is given by this. At what time is the particle at rest? The definition of a particle being at rest is when the velocity is equal to 0. This is when a particle is at rest. So to get to the velocity, we have to take the derivative of the position function, which is going to be 6t squared minus 42t plus 72. We want to set that equal to 0. I can take out a 6, I believe. If I take out a 6, that's t squared minus, and then I believe we get 7t plus 12. So we're going to get 6 times t minus 3, t minus 4 equals 0. So you're going to get it t equals 3 and t equals 4. The particle is going to be at rest. Choice C. And 26. Oops, sorry. 26, bring it down. What is the slope of a line tangent to the curve of this? at the point 3 comma 2. So again, this is implicit differentiation, so you're going to have to solve for this for dy dx. So I'm taking the derivative because I want to find the slope. And again, it's only the slope, that's all I'm interested in. So this is going to be 6y and then dy dx minus 4x equals derivative of 6 is 0. Then minus, this is going to get interesting because it's got to be, that minus has got to be on the outside. This is the product rule. Derivative of the first is 2 times the second is y plus the first, which is 2x, times the derivative of the second, which is dy dx. Alright, so what we want to do is we're going to distribute that minus sign through, so that makes that minus and that makes that minus, and then we're done with that piece, and the parentheses aren't there anymore. And then I want to get the dy dx's on one side and everything else on the other side. So I'm going to move this minus 2x dy dx over to here. So I'm going to get 6y, alright, dy dx. I'm going to move the minus 2x over, so it becomes plus 2x dy dx. That's that. Now I've brought that over there. The minus 4x I'm going to bring over here. The minus 2y is going to stay, equals minus 2y, and then the minus 4x becomes plus 4x. I'm going to factor out a dy dx, so I have dy dx times, this will be 6y plus 2x equals negative 2y plus 4x, and then divide both sides by that, so you have dy dx is going to equal negative 2y plus 4x, all that divided by 6y plus 2x. Now they're interested, that's the slope, this is what m is, but they're interested at the slope, to find the slope at x equals 3 and y is 2. So we're going to plug that in, minus 2 times 2 plus 4 times 3 divided by 6 times 2 plus 2 times 3. So this is a negative 4, and that's a positive 12. So negative 4 positive 12 is a positive 8 over. This is 12, and then this is 6, 18. And when I reduce that, because I believe it's going to be reduced by 2, you get 4 over 9. Choice B.